So this presentation is managing 1,500 routers with a single click or a network automation tail. A little bit about me. My name is Thomas. I'm a system architect, Mikrotik certified trainer, consultant. I'm here with Unimus. We are a network backup and management solution. We have a stand. Come and visit us at our stand if you want to talk about it. And so why are we talking about this topic? Why am I making this presentation? Well, network automation is definitely the way to go forward. And there is sadly very little material on how to do it properly. And another reason is that I recently completed a project that deployed 1,500 Mikrotiks in a nationwide network with full automation. So yes, let's talk about how to automate and how can automation make a project like this better and how to do it properly, some of the challenges we faced, etc. So before we go any further, a little disclaimer. The implemented solution is actually under NDA, so I cannot show you any direct screenshots or the demo of the system. But I did receive approval to talk about how it was implemented, what we used and how we used it, and therefore I can actually talk and explain to you what is needed to implement full automation in a project like this. So the massive thanks go to the people that cannot be named due to the NDA for actually even allowing me to present all of this information. So yes, let's talk about network architecture first. Because if you are going to do a network, the first thing you should do, hopefully, is architect it properly and decide what are you going to do and how are you going to do this. So how are we going to do this then? So first, let's look at our backend that was used for this particular network. Or in this case, it would be your data center, right? And in our case, we had a transit network, which we will talk about in a second. That's another layer. But in our data center, we just had 2 edge routers that were connected to 2 switches, fully redundant. Then we had some VPN access concentrators, which I will also talk about in a second. Then we had some internal routers, also redundant, and then some servers, which provide services for our infrastructure. So in this particular project, actually, this was a private nationwide network. So we had servers which were not publicly accessible, but dedicated for this infrastructure to provide services. And yeah, this is where you would put your servers. Of course, internally, you may have multiple subnets here. That's another debate. It depends on what you need. And very important here is, of course, that your servers and your storage and everything else should also be redundant and redundantly connected. And ideally, if you are doing a bigger project like this and you need to offer SLAs, etc., you also want to have a failover site for backup reasons. And so I have a little note about VPNs that you may or may not want VPN access concentrators here. So why? Because it depends on what you use for your transit. So let's talk about the transit network. So the second part of the architecture is the transit network. So this is how your routers or how your users connect directly to your services, right? They have to somehow access those servers in the data center. So that's the goal of the transit network, to provide connection to you, from your users to your services. And here you generally have 3 options if we are talking about a nationwide network. You either build your own transit network, which, let's be honest, not very realistic, right? If you are going to build your own national scale network for reasons of transit, then that would blow up the project costs and the timeline and everything just to unrealistic sizes. So the second option is to buy WAN services from an existing carrier or a transit provider that already has infrastructure built across your entire country. And the third possible reason is actually just to use the internet, right? Because everybody already has internet. All of your sites, preferably, or generally, already have internet accessibility. And even if you are building an entire new network, those sites will definitely want internet. So realistically, you have 2 options, right? So if we are talking about, again, a nationwide, nation-scale network, option 2 will generally provide best stability, SLAs, and consistency and services. And this is, of course, because when you buy a transit, when you buy a transit from a national provider, that provider, the single provider you buy from, first of all, you are buying in bulk, And second of all, it's consistent because it's from a single provider and you can get consistent SLAs across the entire network. So let's talk about the internet. So internet will be the cheapest option, although most problematic one. Why? Because it's the internet, right? If you are using internet for this, there is a very good chance that every single site that you deploy will have a different provider with different speeds, with different SLAs, with different connection options, PPPoE versus static IPs versus dynamic IPs versus hotspot, whatever you have. And also, you will not be able to get consistent SLAs and consistent network configuration for your client. So the choice here is really up to you. For us, we decided to go with option 2. So we actually bought WAN services from a national carrier. And like I mentioned, this is because of mainly SLAs and consistency and dealing with a single entity instead of dealing with 100, 200, or even more small entities. So what about the users, right? So what about the actual subnets, actual site that terminate our users? How do we architecture this? And this depends on a few things, again. The choice of transit, and if you are building a new network or interconnecting existing sites, existing networks. And the third, I guess, consideration would be, do you even have full control over your customer sites? And we'll talk about this in a second. So like we mentioned, in our particular case, these networks already existed. So they were pre-existing sites, meaning they were already set up somehow, usually like this. And all the sites which we needed to implement into our unified solution already had internet from various providers with various cheapest brand routers from their providers. That's why they were configured like this. So we could have forced unified addressing, and we could have forced router change on every site. We could have done this, that, but let's be realistic. Forcing 1,500 sites to completely readdress is a huge effort. And to completely re-engineer those existing sites, it's a huge effort in amounts of time, which equals in amounts of money and in problems it would cause, etc. So sadly for our project, since these were already existing sites, if we were to actually force them to be unified completely, even in their local network, that would have been unacceptable because of cost and time to implement the project. So yeah. So why did I say that this depends on many things? So first of all, the choice of transit. If you choose to build your own network, you would engineer these local sites differently than if you use the internet and if you use the WAN services. Because theoretically, inside of your own network, you could provide internet inside of the transit as well. Or even if you buy transit from a national carrier, you can theoretically provide internet over that as well. But if you are terminating a separate internet connection and a separate upstream WAN connection, then you would need to engineer the local subnets differently. So there are, again, considerations of how to implement this even on the user-facing side. And it depends on your project or on your particular use case, how to actually engineer this part of the network as well. So in our case, the simplest, cheapest, and fastest solution was to simply add a Mikrotik to every single site. And if something is cheapest, fastest, and simplest, it's very hard to argue against. So we simply deployed another Mikrotik router at every single site alongside whatever they already have. So we didn't touch their existing infrastructure in any way. They kept their addressing, they kept their previous routers, they kept their previous internet connections. We added a Mikrotik and we connected that to our transit upstream WAN. And since this required minimal change to existing networking on our sites, that means we could implement the project much faster and for much cheaper prices and with much less customer impact, since we didn't actually impact their existing networks at all. Okay, so that was our solution to our problems. So we built our own data center where services were located. We purchased transit services from a existed nationwide provider, and we decided to implement Mikrotiks at every single of our customer sites. So what about our problems? So first of all, what about routing? So how do we get clients to send the traffic we want over the new Mikrotik routers? And luckily, all of our client PCs were already in AD, which is Microsoft Active Directory. So single GPO rule took care of all of this. And this is not ideal at all. Why? Because only computers which are down here, which are in Active Directory, actually have any way to communicate over our new dedicated service, because only those actually have a route. So this is not an ideal solution at all. But like we mentioned, since this router is whatever, meaning the cheapest brand there is, which has no functionality, then there is no real way to force unified routing on all of those subnets. So this was our solution. And as I said, not ideal, but it worked for us, and it's very hard to argue against it with the upper management if this is the simplest, cheapest, and fastest solution. So what about the second problem? What about subnet duplicity? We mentioned that sadly, everything was configured somehow, usually like this, because the local administrators and everybody just didn't think there would ever be a unified network. So we had subnet duplicity. But for that, luckily, Mikrotik has netmap, and netmap was our answer. So netmap creates a static one-to-one mapping of one set of IP addresses to another set of IP addresses. So we created a unique virtual subnet for every single site, and then we used the subnet with net and netmap to ensure unique addressing. This means that basically, from the outside, every single site appeared to have a unique /24 living inside of it. But realistically, this was net mapped to the duplicit local subnet. So sadly, again, not the cleanest nor best solution, but a valid one for us. So even if we don't like it, even us network architects sometimes have to make compromises. We don't like it at all, but it's hard to argue against the clients. If you have a certain deadline and if you have a certain amount of money to do the projects, sadly, sometimes solutions which are not ideal have to be taken. As long as they work, as long as they don't have any vulnerabilities and etc., it's still a valid solution, although not the cleanest one. And this all comes to the fact that this was a pre-existing, you could call a legacy network, which needed to get interconnected and organized. So a little tangent, where is IPv6 when you need it, right? So IPv6 would have made this project much, much easier. But sadly, our oldish existing networks were far from IPv6 ready. And the various random internet providers at our sites were very far from IPv6 ready. And also, there wasn't enough money in the project to allow full IPv6 deployment because of the requirements of the overall networking rehaul, of all the local networks needed to be migrated to IPv6 capable, etc., and excuses and more excuses. And yes, these are really all excuses. IPv6 is there. It would have been so much easier to do this project if in the year 2016 we were already IPv6 capable. So yeah, there is no avoiding it. We all just need to do it. So please think about IPv6. Tangent over. So Mikrotik to the rescue, because it's the right choice. So Mikrotik is ideal for a project like this. First of all, because of the awesome feature set that Mikrotik has. It had all that we needed for this project. And of course, Mikrotik Router OS can do much more than just what we are using it for here. And it's the best price-performance ratio you will find. And imagine the price difference between deploying 1,500, insert whatever big vendor name here, routers, and 1,500 Mikrotiks. So imagine how much happy the management people are going to be when you tell them they are going to save potentially even 400 or 500 euros per site, right? It's a huge saving in a big project like this. And also Mikrotik is great for automation. And since this project implemented full automation, it works great for us. So we talked about architecture. Are there any questions for the architectural part? Yeah, go ahead.
Not important, but I'm just curious to hear what country this was deployed in.
It was deployed in Slovakia. So yeah, that was the question, what country it was deployed in. Any other questions? Yeah?
How are you going to access the servers, the services, the non-internet services over the WAN?
Okay.
DNS, I think, and also, why did you not think of putting the Mikrotik in line between the local network and the local router, and then splitting it off for a local egress point amplifier?
Okay, so two questions. First question is, how do we access, or how do the clients access the services in the data center? The fact that all the PCs are in Active Directory is what saved a lot of time and a lot of cost for us, because with GPOs, we could deploy things onto the local computers, which would affect their routing table and their DNS. So the DNS actually goes to Active Directory Microsoft DNS servers, which actually resolve all the host names for those services into the IP addresses in the data center, and then the routing tables of the computers knows that to send traffic to those addresses, it goes to the Mikrotik router on the network. Does that answer the first part?
So how were they connected to the central AD?
Yes, it was actually 8,000 computers were in central Active Directory, in single Active Directory domain, yes. So Active Directory really came to the rescue for us here. But that was because the project allowed that. The constraints of the project dictated that only the 8,000 computers inside of the single Active Directory domain needed to access the services. And like I mentioned, not an ideal solution, but cheapest, simplest, fastest. And the second part, why didn't we simply put the Mikrotik between here? It couldn't have been done everywhere. That's the fast answer. It could not have been done on every single of the sites, because, for example, some sites have PPPoE here, so we would have to terminate PPPoE on the Mikrotik. Other sites have something else. It would have brought too much randomness and too much just too much non-uniformity to our Mikrotiks that we were not willing to accept. Also, at some sites, actually providers manage these routers, right? And you have things like providers log their DHCPs to certain MAC addresses. Just on our scale, it was it was too much hassle. It was too much problems. It was too much reconfiguration, which means too much time, too much money. Does that answer the question? Oh, so why didn't we put it here? Same answer, really. Too much non-uniformity, because we would have to deal with having to reconfigure this. On some sides, we did, it's a lot of work. Whereas this is a really simple solution that takes minutes. Hope that answers it. And yeah, I mean, we could talk about why, pros and cons of either of the solutions. Definitely, you could find some pros in the solution of putting it here, and you could find some cons in solution of putting it here versus here. But this was, after much consideration and much, deliberation, this was the right choice for us. And of course, the choice would have been much different if we didn't have Active Directory, because then probably the solution of putting it here would have been the easier one. But since we had the option of mass configuration change for the client PCs, then yeah. Any other questions? Yeah? Okay, so the question is, why use layer 7 to use a... Yeah, yeah. Any other questions? Okay, can we go on? All right. So yeah, Mikrotik to the rescue. Okay, so let's talk about why what we want to achieve here. Why do we want to automate, and why is automation beneficial in a project like this? So let's first go over the traditional approach of how to deploy networking services. So the traditional approach would be that a network admin configures the router somehow manually. So in our case, 1,500 routers times 5 minutes per router equals to about 16 work days. So that's about a month of actual configuration of those 1500 routers. And yes, there can be some automation done even here. You can use FlashFig, you can use all kinds of things, but in the end, you still need to upgrade router OS, upgrade router boot, deploy the configuration somehow, and it's manual. It's mostly manual. So yes, this can be taken down some. I'm not saying it can be, but let's talk about the completely traditional approach. So yeah, then after the networking admins configure the devices, the techs actually go out and install the hardware. And there is actually another problem here as well, because if you configure those devices and then they lay in storage for a month or two because the techs are going to deploy or there's been some issues or whatever, it might actually also happen that this configuration is already stale. It's old because you have a newer version of configuration because of compliance issues or other things. And so yeah, techs go out and install the hardware on various sites. So if there is a problem at site X, if there is a problem X at site Y because Z, it's wait time. So there is a problem in this particular location because something, it's unstandard, or because it just doesn't work, or because their switch is blocking our router. So it's always, wait time. And something site-specific can cause this wait time, or pre-deployed configuration or router is wrong because it was done manually. So this means you need to create a ticket, or the tech that goes out and installs needs to create a ticket. That then needs to get assigned to a networking guy who needs to fix it, and the tech needs to go back to validate that everything's working. Manual process, right? And the third problem with the traditional deploy is, can this new box also do X? So we are already deploying 1,500 new Mikrotiks to 1,500 sites that already have some networking, but in our case, for example, a lot of the sites didn't have local Wi-Fi. And since we are already putting a new box at all of the sites, it would have been nice to also give them Wi-Fi if they don't have it, right? So in a traditional deploy, it's, again, wait time. Create a ticket, somehow configure SSID, somehow configure wireless PSK, then distribute that to your users, validate that it all works. There is tickets, there is support center calls, just wait time. And we actually calculated this, and it was non-negligible cost for us. Because for us, in our support center, every single ticket was actually quoted at 15 euros. So one single customer call, when you account for all of the time, just everything that there is to do with the ticket until it gets solved, 15 euros per ticket at 1,500 sites, even if just 10% of those sites create tickets, it's non-negligible costs. So that's how the traditional deploy would be done, and that's also the problems with the traditional deploy. So let's look at the maintenance. Because the deployment of a networking topology is just the first step. You also have to maintain that network. So for the traditional deploy, when a new router OS and router boot come out and you want to upgrade your network because of security risks or because you need new features of router OS, so approximately 2 minutes per router, I think that's fairly good timing to upgrade router OS, reboot, upgrade router boot, reboot. So it's about 2 minutes. So it's about 7 work days per upgrade. And you can imagine if you upgrade just 5 times a year, every 2 months, that's fairly, fairly okay. That's a lot of time, which equals a lot of money. So let's deploy a configuration change to 1,500 routers. For example, because we have new compliance policies, which we need to comply with, or because our compliance detects that we have a security error or a security hole, or we simply want to deploy a new service to the routers or something else. Well, for every single configuration change, we take 1 minute because, log into the router and change something, verify that it's changed properly, that the new service works, log out. So it's about 3 work days per every single configuration change. And you can imagine how this goes into money real fast, because time equals money. And yeah, and something specific at site X. For example, we want Wi-Fi, or we want to change our SSID, or we want to change our Wi-Fi PSK. This is a really common thing, right? So again, support center calls, tickets, manual admin work, potentially different config at each site. It's a nightmare. So there is a lot of non-uniformity which is introduced into the network over time. If you imagine that over a span of a year or 2 years, and manual configs and site-specific changes to every single site because of support tickets, your network, just your uniformity of your configs break down. And also, users are not very happy because let's be honest, how many of your users actually call your support center? Some do, of course they do, but usually users just, something doesn't work, there is a spinning wheel and it doesn't work, the network doesn't work again, and they just go off, get a coffee, and sometimes you don't know for days because users, right? So, like this, it actually also creates issues for your users. And ultimately, our goal is to make our users happy because that's what gives us money, right? So let's look at the automated approach. So first for the deployment. An automation system is put into place. Then data is fed to CMDB. We will talk about what CMDB is in a second. And this is not manual work. You just run a whatever SQL script to feed the database. And how do the data get into the script? Well, for that, you have the data entry team. The networking admins don't have to do anything. And we all know that data entry is much cheaper than real IT work, right? So yeah, you fed the data to a database, and then the techs go out and install the hardware, and click a single button in a web portal to provision the router. And then we introduce a self-service portal for changing various site-specific things. So, how is this different from the traditional deploy, right? First of all, this is completely deleted. This doesn't happen anymore, but is replaced by the time it takes to implement the automation system. Techs still need to go out. So if there is a problem, this is mostly eliminated because site-specific things were already taken into account when you fed the data into CMDB. And the pre-deployed config on the router is wrong, that's impossible, right? Because the automation is provisioning, is making the configs. Well, I say impossible, but humans make a lot of mistakes. Computers, well, they make less mistakes, right? So yeah, can this new box also do X, like deploy Wi-Fi? Well, in a automated deploy, and usually automated deploys like this, actually deploy a self-service portal which allows users directly to change, to influence the config. For example, in our case, we created a single web page, we will actually talk about this later as well, where the users could click Enable, Disable Local Wi-Fi, fill in their wireless PSK and their SSID and PSK, click Apply, and their site would automatically have Wi-Fi. And you notice there is no support calls. They don't have to call somebody. Somebody doesn't have to directly connect to their router and configure it, etc. So the self-service portal makes a huge difference to user-customer experience and much improves their satisfaction with the service because they, with a few clicks, can actually influence or change SSID or Wi-Fi PSK versus having support calls, waiting, And also another big advantage of the self-service portal is that we can now display per site or site-specific health data. Like, is the speed on your link okay? Is the latency on your link okay? Do we have a known outage in your region, etc.? And this site would be reachable over the normal internet, so it would be like an out-of-band connection. And this makes a huge difference to your customer satisfaction as well, because if something doesn't work, you just teach your users to, connect to the self-service portal and check the health of the network. And you can imagine if a user connects there and there is a little message saying, we have a known outage in your region, it will be fixed in 2 hours. The user will be much happier than just, the wheel is spinning, it doesn't work. I have to call somewhere again, I'm just not going to call, I'm just going home for the day. So there is a big difference to user experience with this and to how your users perceive your service and perceive your network as a whole and how they interact with it. Okay, so that's the deploy. Let's talk about the maintenance. So upgrade router OS and router boot on 1500 routers. It's actually 1 click and 2 minutes. Because the automation does it, you actually replace 7 work days per upgrade to 2 minutes, 1 click per upgrade. So you can imagine the huge time and therefore money savings this generates. So deploy a configuration change on 1500 routers. It's actually 1 click, 30 seconds. And this changes a lot how you as a network admin interact with your network as well. Why? Because making changes to the configuration of your entire network becomes very easy process, which means you can much more rapidly adapt to change requests, to adding new services, to patching security holes, and etc. So you can imagine how being able to do this very much changes how you interact from an administrative point with your network. And something specific at site X. For example, we want Wi-Fi. Yeah, we've got the self-service portal. Just go there and enable your Wi-Fi. And there is no pre-shared key entered in a phone call, or it actually minimizes attack surfaces as well. So users actually do this. Of course, the self-service portal is HTTPS, so there is security there. And I know I'm skipping over a lot of stuff and not dealing with security, but that would make this presentation last forever. So yeah, users actually go to the self-service portal, do something or apply the configuration change they are allowed to do. And of course, we would only allow users to influence non-essential things in a config, like SSID or pre-shared key. And they immediately have the nice feedback that I click apply, there is a 30-second outage, and suddenly we have new SSID or new Wi-Fi password. And I have to go back to how users feel about this. This is what we described, very different user experience than calling support center, creating tickets, dealing with wait time. All of that is eliminated. What I'm trying to tell you here is that an automation system actually influences a lot of behaviors and a lot of factors outside of just networking. It's about the admin experience, it's also about the user experience, it's also about networking consistency, it's also about minimizing attack surfaces. Why? Because consistency means you can audit your network as a whole instead of every single device. If you have an automation system that assures configuration consistency across your entire network, then dealing with audits, dealing with security, patching holes becomes much easier. So I could go on and explain all kinds of things, how this changes, how you interact with your network, but I'm going to leave that to your imagination due to time constraints. So yeah, welcome to the dreamland. Human error is eliminated, well, at least as much eliminated as we can do it. Client customer satisfaction is much improved. Much cheaper in the long run. We actually did calculations, and it's so much cheaper in the long run. And you can imagine from all of the numbers that we already discussed. Much healthier network because of things we already discussed as well, such as configuration consistency, fast adaptation to change requests, fast patching of vulnerabilities, etc. Mass changes and upgrades are become painless instead of a nightmare of different config and different version on every single device in the network. And it's a data-driven approach. As we mentioned, we have a database in the backend that actually keeps all of our configuration data, so we can actually do different analytics on the CMDB, which is the configuration management database. We can do revision history, and we can, and we can suddenly look at how our configuration on every single site has evolved over time. And as I mentioned, this has many different advantages outside of just the networking itself. So yeah, I am a wireless ISP or an ISP, so how does this apply to me at all? Well, even as an ISP, you will inevitably have cookie cutter configs. So configs that are really the same, just slightly different, like CPEs, right? How do you do it normally? You have a template anyway that you just modify and apply, right? So basically, even for an ISP, customer CPEs or customer routers, brasses or PPPoE access concentrators, access points and wireless bridges, switches, tons of switches, right, etc. You already have cookie cutter configs anyway. So we already have much of the things which are similar, just not exactly the same anyway. So you should at least consider automating configuration provisioning and management on configuration on all of these. And this is actually what we are going. Well, any questions before we move on from this section? All right, no questions? All right, so we keep moving. So yeah, when should you actually automate and when should you not? And we tie into this. So I personally would consider 3 metrics to be very important when deciding whether to automate your network or not. First of all, metric 1, time to implement automation versus time to do the tasks manually. And as we established, time equals cost. So it's about time and cost because they are intertwined in our business. Metric 2, cost to implement automation versus cost to do the tasks manually. And metric 3, other benefits of automation. So is it worth doing it for the other benefits which I receive from automation? So let's talk about this a little bit in detail. So yeah, metric 1, time to implement automation versus time to do the task manually. I think that's pretty obvious. And you can calculate this in different ways. But don't forget to account for initial deployment and also for maintenance, because both of these things can and should be automated. And in any sizable network, 300 plus devices, automation will become favorable really fast in this particular metric. So metric 2, cost to implement automation versus cost to do things manually. And this can be quite hard to calculate depending on many factors. Cost of developers versus cost of network admins. Ability/price of right developers. Complexity of the automation system. And this is a big one. Because the more complex the automation system, the more time equals money it's going to take to implement. And therefore, with large-scale uniform networks, this metric is very favorable. In smaller scale or with complex, diverse networks, this metric becomes less favorable. So metric 3, other benefits of automation, which we've already discussed. Elimination of human error, unification of configuration across your network, one-click reprovisioning, config changes, etc. Improved network and service quality. And you can now offer better SLAs. And this ties because of less downtime, because of unification of configuration. For example, you want to upgrade your entire network, just do one click at 3 a.m. and the entire network is upgraded in 2 minutes, versus admins manually upgrading the entire network over 7 days. That's a huge difference, right? So with this, you can actually provide better SLAs as well, which is better money for you, and et cetera, et cetera, et cetera. And here, automation wins big time. So what's the conclusion? Me, personally, I'm a huge pro-automation enthusiast. I love to automate everything because in the end, it makes my life much easier, and it's much less error-prone. And I honestly think, based on facts and many previous projects and experience in this field, that the automation is the right call. And also, this is not just my opinion, other fields in the IT industry are also moving to automation, like DevOps. DevOps is a huge pro-automation movement, right? Virtualization. And virtualization is about many things, but one of the benefits of virtualization is also automation. You have templates which you deploy, you don't install machines manually anymore, et cetera, et cetera, et cetera. And I could go on, but we'll just continue to save time. So yes, consider previous metrics and decide for yourself if automation is the right call for your network. Any questions for this section? All right, we'll move on. So let's talk about the actual automation. So automation basics. So let's start from the beginning. The anatomy of a network automation system. Component 1, CMDB, so Configuration Management Database. Component 1, which is a part of it, is a self-service portal that allows users to change selected things in the CMDB. So CMDB actually holds our per site unique things like wireless SSID, wireless PSK, IP addresses, all the unique things, right? And then a self-service portal which allows users to change certain things in CMDB. Component 2, the actual provisioning system, monitoring system, upgrade system. And this all comes into a single component really, which is the NMS, Network Monitoring Management Solution. And you need some way to synchronize CMDB and NMS. So you don't want anything manual. So you just want to add a device or a site into the CMDB, and it will automatically be added to your NMS. And then component 3, backup system. And we are not talking about the backup system for your servers, which you should also have, right? We are actually talking about the backup system for the configuration of your routers. And we will talk about each one of these in detail soon. And again, you want some synchronization system between the CMDB and the NMS and the backup system. So here is a little picture. So we have users down here which interact with your self-service portal to be able to change certain things in CMDB. And also your data entry team fills CMDB with various sites. Then you synchronize that to the NMS, which is provisioning, monitoring, and upgrade. And you have your backup system down here. And then you have 1,500 Mikrotiks. So NMS actually pushes the configuration over SFTP and SSH and does monitoring over SNMP, etc. And backup software backs that all up over SSH. So let's talk about every single component a bit more. So component 1, CMDB, as we mentioned, keeps all the data about our routers. And the self-service portal, we also discussed this. One additional benefit which we also discussed is the users can actually see the health of their network. So what did we use? We actually used the existing inventory system, which was already in place at this organization, customer, whatever we call it, as the CMDB, because it allowed us to inject custom fields that we used for unique router data. And for the self-service portal, we wrote a simple GUI as the self-service portal. It took under 2 days for an experienced developer. And just remember security, 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 which we don't discuss here. So as you can see, this is actually not much time. Under 2 days, single developer, self-service portal done. And then you can use some systems which are commercially available, or you can just repurpose the inventory system, which the organization of this scale will have anyway as the CMDB. So component 2, NMS, and this is really the heart of our system. So NMS makes sure that all the routers are on the validated RouterOS version and handles upgrades during provisioning and handles mass upgrades later on. Also takes care of provisioning config to new routers. So it generates router unique config from a template and per router data in CMDB and provisions that onto the router when necessary. And also does full monitoring of our entire topology. And yeah, a slight tangent again, monitoring, monitoring, monitoring. So proper monitoring is absolutely essential. It is in fact so essential that I have a separate MUM presentation just on this topic. You can find it on YouTube. I really think monitoring is the most important part of the network other than the network itself. And without proper monitoring, how do you know the difference between I think everything is okay in my network and I know everything is okay for a fact? Because that difference is huge. And how do you offer SLAs without proper monitoring, and et cetera, et cetera? This is a huge topic which we could discuss for days. And as I said, if you want more on this topic, you can check out this presentation. And yeah, proper monitoring system really needs to be independent, which means that you are not there to monitor your monitoring system, right? Your monitoring system and your network in itself needs to tell you when there is a problem. So you are not there to monitor your network. You need to be notified when you need to take care of something. And your monitoring system should do that. So what did we use? In our case, we used NetXMS as the NMS. It's an open source NMS system, very flexible and extensible. As I mentioned, see the MUM presentation on the previous slide if you want more info. And we wrote our own provisioning and the backup scripts. And initially, for the proof of concept system, we actually used TLC plus expect scripts, which was really easy. I wrote that in under a day. And for the final solution, we actually use Java with JShell and expect. And another slight tangent here. I get a feeling that Java has a really bad reputation in our industry. And I really think it's undeserved, and I don't want to talk about it because it would take too much time. But for us, it worked great. I really love Java. And if you want to talk about it and argue about it with me later on, we can. So yeah, on the Mikrotik side, as previously mentioned, RouterOS is really comfortable to automate around. For upgrade, simply upload the appropriate package over SFTP, security, 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 connect to over SSH and reboot, very easy. Or send SNMP trap, whatever. There are many ways. You can find out all of those ways. And for configuration provisioning, simply upload the per router generated RSC over SFTP, security, 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 and execute this little command. And suddenly your router is provisioned with the new configuration. So CMDB NMS sync. So when a router is added to a CMDB, it needs to be automatically added to NMS. And periodically, you need to sync these two systems So you only have a single point of interaction between your entire network and topology and configuration and you. In our case, the single interaction point was the CMDB. So we added something to CMDB. It gets automatically synced into the NMS and all other related systems. Nothing should be manual, automation. So what did we use? We wrote a little piece of software that connects to CMDB and NetXMS over their APIs and simply does a diff. So adds things, remove things, etc. This simply runs in cron, and or you can execute it manually. And I'm not going to go into why cron and other things. We do things with Puppet, so Puppet assures that the cron is always present, etc. That's a discussion onto itself. So component 3, which is a configuration backup system. And so you should always have a configuration backup system. Whether that's in an automation-based network or in a manual, traditional style network, doesn't matter. You should always have a backup system. And even if with full automation, config backups are necessary. It's your last line of defense. If your provisioning system breaks, you can always go back to a valid, known valid configuration. And this enables you to offer better SLAs, better quality of service, etc. If someone or something wrong SQL script or that data entry team made a mistake, so if data in CMDB somehow changes or gets corrupted, you have a backup from the working point for that router. And also a backup system actually allows you to run analytics on actual deployed config history, not just on what you think CMDB should be generating, right? And yeah, disaster recovery, that's a huge topic, etc., etc., etc. This also allows you, for example, to see if somebody has made manual changes to your routers. Because the backup system can see if the config that it backed up last time is different from the config it backed up this time, it can actually notify you when there was a manual entry into the configuration, which you want to eliminate. Because in an automation-based network, manual configuration changes on devices are your complete enemy. Just uniqueness is an enemy. You want everything to be nice and consistent. What did we use? We used Unimus, self-promotion warning. So yeah, this is our solution. I'm not going to talk about it because self-promotion, but I will tell you your other options, which are rancid or oxidized, or you can write your own script. If you want to talk about Unimus, as I mentioned, you can find us at our booth. We'll be happy to tell you why our system is better than this and why we chose it and etc. And yeah, you need to somehow synchronize this to your CMDB or NMS. So when you create a new device in CMDB, you don't have to manually add it into your backup solution, which, as we mentioned, it's an automation tail, so nothing should be manual. So what did we use? Unimus has a native NetXMS sync connector, so everything just happens completely automatically, more self-promotion warning. If you use something different, you will have to implement this yourself somehow, or your system has to have some kind of a way to connect to those other systems. So that's the entire picture again. From the user all the way to the 1500 Mikrotiks. Hopefully you understand now how this all fits together and the entire picture. So the demo. And this is usually the part of the presentation where I would do a demo and show you how everything works. But while I would really love to, sadly I can't because of the NDA. See the disclaimer at the start. I can, however, tell you how it all works and how it behaves. So when adding a new router, how do we add a new router into the system? A new router is added to the CMDB with its appropriate router unique, site unique information filled out. And this is done by the data entry team. Then an installer is dispatched to the field, and he installs a fresh, out-of-the-box, untouched Mikrotik. So there is no pre-configuration, there is nothing. He just picks a Mikrotik out of the pile, whatever one. He doesn't have to care if that's the proper router for the site. There is no concept of a proper router per site. It's all automated. So installer picks a fresh out-of-the-box Mikrotik, installs it at the site, logs into NetXMS, locates his router in NetXMS, and presses provision router, and it's done. So that's the automation, right? Installer picks a box, plugs it in, presses provision, done. So the automation effect. This is, of course, much faster and much simpler than a traditional non-automated method. Much less error-prone. You know, we already talked about all of this, so I'm not going to repeat that. It ensures consistency and all the other benefits we discussed. So another thing, how do we deal with clients or customers that want to change something on their config? Well, if the customer wants to change something, they just use the self-service portal, right? They log into the self-service portal, they change what they want, they click apply changes, which updates data in CMDB, and their router is provisioned. Done. As we discussed, no tickets, no wait times, no nothing. Much better customer experience. So yeah, we actually just talked about that. And another, yeah, like I mentioned, we didn't discuss security, attack surfaces, and all of that because it's a huge topic. So yeah, when updating router OS, how do we deal with topology-wide firmware or software upgrades? Well, a network admin logs into NetXMS, selects a group of routers or the entire network topology of 1,500 routers, and clicks upgrade routers. That's it. Suddenly, through automation magic, 1,500 routers are upgraded to the latest verified approved router OS. And this, of course, assumes we tested the new version in our lab. It passed our change management processes. It passed our change validation, blah, blah, blah. So, of course, those things need to happen. You don't just deploy a new version of software to 1,500 devices, never. You have to test. This is a topic which also is a topic onto itself, how to do change management properly, which we will not get into. So yeah, automation effect. Imagine how difficult this would be without automation. Well, actually, we calculated that about 20 minutes ago. So yeah, total network consistency is achieved, attack surfaces are decreased, and much more defined. It's also about the definition of the attack surfaces, since you are running a single verified version of your operating system. Because all your devices have the same attack surfaces, whether they are there or they are not. And if they are there, they are network-wide. So it becomes much easier to deal with compliance issues, with compliance requirements, etc., etc., etc. Okay, so how do we deal with changing something in our entire topology? So when a configuration change is needed, for example, because we deploy new services to our network, or because auditing shows that our currently deployed configuration has a security compliance or issue, etc., etc., etc. Our compliance requirements change. You can imagine there is many different reasons for why a configuration change would be needed. So we just update our configuration template, log into our system, select a group of routers or the entire network, and we press provision routers. Yeah, we are running out of time, but that's good because we just have a few more slides. Okay, so yeah, 1 minute later, the entire topology of 1,500 routers is running the new configuration. And this, of course, assumes, again, we tested our configuration in the lab. It passed validation and change management and change validation processes, etc., etc. So yeah, the automation effect, this would be a nightmare without automation. We talked about why. We talked about consistency and everything else, so I won't repeat all of that. But the real winner is that reaction time to change requests to security issues is massively, massively decreased. And yeah, that's actually it for the presentation. As I said, I would love to show it to you how it actually behaves, but I can't. So some additional resources, so things to watch or listen to if you want to know more from me. Yeah, for my other MOM presentations, I am on YouTube. I have a bunch of presentations on YouTube if you are interested. MPLS, VPLS, deep dives, monitoring, like I mentioned. This is a good one if you are interested in that. I am a part of the Brothers Wisp, and we are a bi-weekly networking podcast. Yeah, give us a listen if you feel like it. You can find us on this website, YouTube, iTunes, Facebook, whatever. And yes, that's it. Thank you very much for your attention. Due to time constraints, if you have any questions, just find me after the presentation or come to talk to us at our Unimus stand. And thank you for your attention.